What we're going to be talking about is a retrospective of something that I've dealt with in the past, of a command gone awry. So more detail about what we're going to be talking about. An incident that occurred at a past job of mine that took down everything. It happened on a Friday, and it happened at about 5 p.m. What unfolded, how we fixed it, what we learned, and what led me to focus a little bit more on incident response, which is what I do on a day-to-day basis now. So, who am I? As mentioned, my name is Bobby Tables, but my real name is Robert Ross, which is almost better because that literally makes me Bob Ross. I am at Bobby Tables on Twitter, GitHub, Instagram. This is me. This is an updated photo from the same exact spot from a couple weeks ago, but much, much colder. This is Lake Louise, beautiful place in Banff, Canada. Highly recommend you go. So previously, I've worked at a couple of companies in New York, namely in DigitalOcean. I've worked in other companies, consultancies like Thunderbolt Labs, 5 others that we'll just totally skip. They are totally irrelevant. And now I am the co-founder and CEO of a company called Firehydrant. We are an incident response tool, firehydrant.io. We like puns, so we named our mascot Patchy. He helps you patch websites, and he's also a Dalmatian. Next slide. I like telling stories. So today, I wanted to tell you a story about one of my favorite outages I have ever been a part of. Now, outage, my version of it, the nomenclature I use, is like anything that your customers are going to email you about. Anyone that's going to like tweet furiously at your Twitter handle, anything like that, that is an outage. And the one that I'm going to talk about dates back a little bit, and it's the Great Table Drop of 2015 at DigitalOcean. This was the logo of DigitalOcean. If you're looking at that going, that's not right, that's the logo I know. Because when I worked there, it was about 4 years ago. Now, a little bit of background. I worked at DigitalOcean as a software engineer. Full disclosure, I was fired. And also, whatever, it was mutually beneficial. Getting fired can be an awesome thing, because I learned a lot, but I'm going to tell you this story anyways. Ruby on Rails application with MySQL database, technically MariaDB, if you're familiar with that stack. All right, now that we've gotten past over like the weird awkwardness slides that nobody really knows how to react to, we're going to talk about the wrong place, time, and terminal window. Now, it was a Friday. It was later in the day. And this story involves a command that ran accidentally in the wrong window. Now, for the unfamiliar, Ruby on Rails has some extremely convenient commands to manage databases. You can create them, migrate them, and yes, drop them. Now, I have a quick little video up here. We're going to watch just how easy it is to drop a database with Ruby on Rails. And I have deleted an entire database with those few swift keystrokes. Now, no production database was harmed in the making of this slide. However, I did check that it was not Firehydrant's production database. I'm going to guess 10 or 15 times. This poses a really interesting problem when things are really, really simple to do, because a lot of people had access to production Rails consoles at the time that this incident happened. And the database didn't have other permissions removed from it, such as truncate and drop permissions. All terminals look the same. And so many other little factors, right? Like if you have 3 terminals open, one on production staging in your local machine, it can be hard to know which one you're about to run a command on. Great. So some other fun during the incident. It's like one of my favorite incidents, not only because it was just like this massive outage and like there was a lot of heroics involved, but just some other fun stuff. Network maintenance was starting after hours at our office at DigitalOcean, which is actually right around the corner from this place. I don't know if that was intentional or not. But network maintenance started after hours, meaning that we had to leave our desks and go to a different conference room in the building that wasn't even on DigitalOcean's network. So this outage happened, and then our network went down while we're trying to fix the outage for network maintenance. Great. And another on-call engineer wasn't aware of this massive team that had just assembled to fix this incident, and actually rolled a delayed replica forward, which meant it also lost all of its data. Now, quickly on that one, for the unfamiliar, DigitalOcean had an incredible team. They still have an incredible team. But what we did is we had these other databases that kind of procrastinate. They kind of watch the primary database, and they'll procrastinate until they doing the actual things happening there. So you have this log of events, and you have a drop table. And the ones that are procrastinating just kind of sit behind like 4 or 5 hours. And what this engineer did, as a very good response mechanism, is they rolled that log forward to try to restore the database. What they didn't know is that they rolled it up to the point where it just dropped itself again. So that was another fun part of this incident that could have, if we had like better communication and all these other things that happen in incident response, maybe would not have happened. But then I wouldn't be here to tell you all about it. So while a bunch of things went wrong, a lot of things went right as well. Now, couple of things that I want to talk about that went just extremely well in this incident. No one panicked. Now, even though this was 4 years ago, DigitalOcean was still serving hundreds of thousands of customers, let alone the VPSs that were serving their customers. So one thing that I found very interesting about this incident, and that kind of helped me and led me kind of to this world that I live in now today, is that this team of people that was sitting there on Friday, and this is a startup, we're all exhausted, we're naturally exhausted, kind of got up and said, okay, we're going to fix this incident. And it was just this very, very natural thing that happened. And I thought that was really interesting, that nobody actually panicked. A few others, like outside of that team, were panicking, but not us, no. Teams naturally manifested, and I thought this is probably one of the coolest things that happened during this time, was that we didn't really say, you're going to do this, and you're going to do this, and you're going to do this. These people just kind of naturally knew, I am really good at this thing, so I'm actually going to talk to customers, restore a database, and my job was to kind of make sure that we could leave some data behind in some of the scenario. And I thought that was really interesting, that nobody really said, I'm going to do this. It just kind of naturally happened. I thought that was great. We acted swiftly. This is a really interesting part, too, because if you think about incident response, and like if somebody is in here, is anyone on a page right now? Like, is anyone on a call? On call? 1, 2 hands. So if you're on call, there's probably a book that you have that helps you determine if it's a Sev1 incident, a Sev2 incident, Sev3 incident. And it's like chutes and ladders to just get to this point where it's like, oh, it's a Sev2. But when this incident happened, there was none of that. Because the reality is, when your customers can't use a service or something that they know that they've previously been able to use, it's always a Sev1 for them. It doesn't matter to them. They just know, like, I can't do the thing I'm here to do, so it's always a crisis for them. Or Sev1. Maybe crisis is a little too, I can't buy my toothbrush on Amazon. Is that a crisis? I don't know. And a fourth thing is that we implemented resiliency tasks afterward. This is another really critical point to keep in mind, because when you're building these systems and you're building software, and I know a lot of people in this room are, you need to be continuously adding resiliency, because that's all an incident is that, using a John Allspaw quote, it's an unplanned investment. It's a piece of time that occurs that's such a good gift to receive. It's like, yes, our system broke. Now we can get better and make it more resilient. Because you only make things that are stronger after things have failed. If wood buildings, never failed, we'd still be building things with wood. So I just thought of that, actually, literally just now. I don't know if that analogy made sense to the people in this room, but Empire State Building would not be made out of wood. Okay. We did remediate the problem by using a delayed replica, same story, rolled it forward right up to the point right before we delayed, right before the drop, deleted that, and then we were able to continue moving forward. relatively simple solution to a pretty critical problem. So I want to give you some of my takeaways, though, and how these kind of relate back to Firehydrant and Apache. Is when you're building a tool, if you're here and you're wanting to learn more about software, building tools, building teams, products, these are kind of my takeaways for this. A tool should help you not think in a lot of ways. And this is the definition for tool, not the band or like an Urban Dictionary version of it. Something used in performing an operation or necessary in the practice or of a vocation or profession. That is a tool. So when we're building our tool, we're making sure that you can declare an incident easily, right? Because if you have to go through this chutes and ladders to declare an incident, you may not declare an incident, or you declare it too late, and now you have pitchforks at your door saying, hey, we actually have to solve this problem now, when you should have declared it an hour ago. Another thing, it should recommend, it should assign the severity for you, right? Like if we're thinking of tools, the biggest thing that you care about in incident response is not the severity. It's not like the word severity. It's not all of these little minute details. You care about restoring service. Your customers care about restoring service. They don't care about the words, really. So your tool should help you assign severity. It should recommend domain experts. We had these teams manifest out of nowhere, but imagine if you're working at a huge Fortune 500 and you have a team on the other side of the world that knows the system that just broke, right? Like, I don't know that team exists, so your tool should recommend domain experts about your systems. And last, it should help you, it should guide you, not prescribe you. This is something that I see a lot of tools do that I really don't like. I mean, it's like another way to maybe say is like opinionated software. But when it comes down to like fighting a fire and building incident response tooling and like all these other, the world of alerting and the PagerDuties of the world, it should really just guide you. It should be like a guiding light. But it should not tell you to step left and to step right. Because that's going to, frustrate you and take away agency. You should feel like you have agency in solving problems, not only in incidents, but for your whole platform. And that's another good way to think about this is that every plane that you've ever flown in, there's a little book in there, actually. You can look this up. And it's basically a list of checklists from the mundane to the extreme. Mundane being like, do we have fuel? Extreme being, if our door blows off in the middle of the flight, what do we do? These checklists exist in a plane, but they're not there to prescribe what to do. They're there to guide what to do. And that's another big piece that we try to build into our tooling based on our learnings. And one of the things that I like about all of these stories and all of these learnings is that like it kind of started out as like none of these happened and I was like, let's build a company. Yeah, we got this. No, it was like we took all these learnings and I started Firehydrant as a side project to teach Ruby on Rails. That's how Firehydrant actually started. It was nights and weekends just spent writing code, ignoring texts and my family, and trying to help with incident response problems that I really had myself. And that's a great piece because now it's a company. It was not ever something that I was like, this would be a cool company. It was just like trying to solve problems. That's really what a company is. You're just trying to solve problems. And what I'll say is that the best products are the ones that solve problems the team building it have had themselves. Every product you've ever used that you loved probably fell into this category. So with that, I'll say, based on all the learnings, maybe you have situations that you've also had that maybe you're like, man, I could solve that. I'm going to say, now go and build it. And that's all I have. I got 15 minutes. I'm going to speak for 5 more seconds because I can say I nailed it. Thanks, everyone.
All right, we'll take
I think I have 5 minutes for Q&A or something.
Yeah, we'll take some questions. Avery and I have mics, so just raise your hand and we'll run them over to you. Who's going to be the first question asker?
After you decided to found the company, I'm curious, where did you hire your first few developers from?
I guilted a couple friends. Yeah, we laughed. No, it was the first 2 people were old friends and engineers. I'll say that people don't buy products, they buy vision. And I'll say that people working for companies are similar, right? They're not, a lot of the time, like, engineers are going to get paid a lot no matter where they go, really. You need to be able to, like, basically offer fulfillment in a lot of ways. It's not ping pong tables, it's not beer, that's not it. So what we try to do in the few engineers that we've hired now is that we say, like, if you want to work part-time and be in that band that you're in, like, that's fine. So we've actually done that. We've actually hired part-time engineers that just want to do other things too. And that's actually helped a lot with our hiring.
Yep. So does it allow you to manage your incident response playbook? And can you associate automatic remediation actions? Or after that, still some manual work will be required?
So our latest hire is sitting directly behind you smiling because we're literally building that right now. Yes, yeah, we are working on those functionalities right now. So the question was, what kind of clients do we have? What is the problem area that we're solving right now? So a lot of our clients are technical, more on the technical side right now. And the problems that they're trying to solve are the process and the communication angles of incident response. Because if you think about when a fire breaks out, like a software fire, not like needing these exit doors that we were told about, it's really the process of it can be lost in the chaos. Like, you just forget, right? So that's really what they're using a product for, is to help them kind of usher in this process and be a culture shock within their business.
One over here.
So how do you differentiate yourself from the big giants like Remedy, for example?
Like who? I'm sorry?
Remedy?
Gremlin?
No, Remedy. 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 So that they also do incident responses as well in the enterprise space. So, which is, I'm guessing, where you guys want to get to as well.
Yeah, so I mean, the easiest way, I guess I can make a joke here, is like just not even know about them. That's a good way to separate. So I would say that our phrase is like, you just got paged, now what? That's really where we are. We're just sitting kind of on, if you're going to get paged, I'll say it differently. Everyone here has a smoke detector in the house. Every major software corporation has a smoke detector. They have PagerDuty, VictorOps, all these other tools. And they're really good to be like, hey, your site's down. Good luck. And Firehydrant's kind of the next step of that. We're trying to be the iteration on top of that. Where we go from there, there are some pretty natural paths that I can see for us, but really just kind of sitting in the response during the time of an incident.
Hello, everybody. I'm Cillian, and I'm here to talk to you about how you build trust in data and engineering stacks, or more specifically, what data privacy means for engineers and data teams. So very quickly about me, aside from being called Cillian and being Irish, I wrote my first lines of code in 1985. It was a balloon in BASIC on a Commodore 64. I dropped out of my physics degree. My mother's still sad about it. And I've then worked in data for the last 18 years. I previously built a business which I ran for 15 years. It was sold 4 years ago. And I founded Ethyca with my co-founder Miguel about 2 years ago. I love math. I think it's art. I like discrete geometry and space. And if I don't focus on those things, I build vintage motorcycles as a hobby. Ethyca, most importantly, what we do at the moment. So we are a technology platform that is designed to create trust in data-driven systems. So that is to say that we try to automate as much of data privacy compliance so that engineers, data, and product teams don't have to think about it. That's the whole goal. It's not that you don't care about it, it's that you're busy doing other things. So we want to remove the friction in CI/CD for data privacy. So I have a lot to cover, and I've been told I've only got 15 minutes, so I'm going to go really fast. And if you don't understand me, come and find me afterwards, because I speak too quickly. So we're going to cover data privacy and compliance and what that means, an abstract model for how you might think about that, because data privacy is legalese in most cases. What it represents in terms of obligations for a business from an infrastructure and engineering perspective, and of course then a summary of what that means for you guys. So data privacy and compliance. Well, the first confusing point about data privacy is it does mean many things, right? There's the sort of personal idea of privacy, and then there's more concretely the definition, right? Which is determining what information you share with third parties. Like, that's the basic tenet of what data privacy is. What that means from a compliance perspective, however, is a little more onerous, right? It's this idea of putting in place appropriate, technical, and organizational controls on everything that you do. It isn't just paperwork and box checking. It's the process that you deploy from a point of view of product design, planning, development, deployment, maintenance. And it goes to the core of your product, right? It's the idea of baking privacy principles into your engineering. And that's what they're trying to do when they impose regulations like GDPR or California's CCPA on you. They're not trying to make it difficult to build things, they're trying to make the system safer for their end users. Of course, for us as engineers, this all feels like a tax, and a very, very unclear tax. So, why? Well, privacy is pending everywhere, right? Everyone's thought about it in the last year, sort of through the lens of GDPR, right? If you're not familiar, the European legislation came into effect in May last year, pretty onerous. Some of the fines started coming out. So British Airways got fined $250 million about 2 months ago. Marriott Group got fined about $120 million. There's been a bunch of smaller fines, but they're the big ones. And there's a couple of thousand pending investigations across Europe. So GDPR is very real, and the teeth of fines are very real for large businesses. We've got California privacy law comes into effect on January 1st, 2020. PIPEDA in Canada is already in effect. LGBT in Brazil comes into effect in August 2020. PBB in Brazil or in India is likely to come into effect in the next 18 months. And there'll probably be federal regulation here in the US after the next election. So the bottom line is data privacy compliance is coming. It's not going away. It's going to compound itself like regulation in banking and pharmaceuticals. So as engineers and infrastructure operators, we've got to think about how we manage this risk and this challenge. So what are the principles of data privacy? And the problem with these is they do sound like legalese because they were written by lawyers and regulators and compliance folk, right? So abstractly, lawfulness, fairness, and transparency is the idea that you should lawfully collect data. Don't worry, I'll make these simple in a moment, or less legalese. Lawfully collect data, make it fair for the user, make it very transparent as to what you're doing with that information. Purpose limitation is the idea that you should only collect the data you need for the purpose that you intended for. Don't collect unnecessary data, don't use it unnecessarily. Data minimization is closely related to that. Data minimization is the idea that those in your organization who have access to data should only have access to the information they need for the job they're there to do. So absolutely minimize the amount of access to data. Accuracy, so allow users to update data that is inaccurate or remove it full stop. You've got to get rid of it. Storage limitations, so don't retain data you're not continuing to process. If you don't have a reason to have it, get rid of it. I know I'm saying these things very glibly, right? This is what the lawyers write. We as engineers then need to figure out how to turn this into something that works in a business. Integrity and confidentiality. Act with integrity. It sounds obvious, and confidentiality is exactly as it sounds. It's encryption in every way that you can imagine, and care as much as possible so that you minimize the exposure during a breach. Of course, this is legalese, as I said, and we have a version of this deck that you guys can have, which has more explanation. But what we thought was helpful is to look at this as a sort of abstract model for how you need to think about compliance in, I suppose, the infrastructure or data stack. So these are the things you really need to worry about and what they represent, and I'll explain them in detail. There's inventory and mapping. There's DSRs, data subject requests. You may have heard this expression. I'll explain it in a moment. Consent and objection, data minimization, and DPIAs. So if you want to group, and it's so important to say, data privacy compliance as it relates to GDPR or CCPA or POPI in South Africa, there are nuances, there are variations. This is an abstraction or a model that you can apply in most jurisdictions, but it's imperfect. I wouldn't recommend this for an organization at scale. But these are the things that anybody working on a data stack should be thinking about. And so the first of those is data inventory or flow mapping, or in Europe they call them Article 30 inventory assessments, right? So there are loads of definitions for what this means. This is what they look like normally. So it's an Excel spreadsheet usually. And basically what it's meant to contain, if you will, is a construct of the personal information the organization stores, processes, and who has access to it. So to explain that in a bit more detail, it's specifically the categories of personal information the organization has. It's also the categories of subjects for whom you have data. Subjects are users, right, of your systems. But subjects are not just a customer. Subjects are also your employees. So if you use Gusto or JustWorks in your business, that HR data, that's fair game under privacy regulations. So those systems have to be meshed together as well. It's who has access to that information, and the who here is important. It's individual users in the organization, like engineers, data scientists, the finance team. It's also services and systems, right? Like it's what batch process is pulling data out of here at night, what is it doing with it? And then that is that that latter point is processing activities or business activities. So this means, what are you doing with the information? So each of those attributes of data. And finally, the basis for processing. So the basis is literally what it sounds like. It's what, I don't want to say what legal right, because that's a very specific thing, but why are you allowed to process this data? Have you got consent from the user? Do you have a critical security reason for doing it? Or does someone's life depend on it? There are defined purposes or bases for processing data, and it needs to be assigned to one of those. If it's not one of those, you shouldn't be doing it, or you can't. And finally, how long do you hold on to the data? Like, what's the TTL? Like, why is it there at all? And so ways to think about solving for data inventory or flow mapping, and rather than give you guys like a specific lesson on one stack, what we thought would be helpful, or I thought would be helpful, was to show you the ways in which you can typically solve each of these things. So data inventory most commonly is solved manually at the moment, right? This is the most common method. So it's aggregate the schema across the organization for all data storage systems, audit anything unstructured. So if you've got an S3 bucket full of stuff, frankly, because often it is just full of stuff that nobody has total clarity on what's in there. Document it, understand what processes are connected to it, like what's sucking data in and out, what's putting it there, and why. And then who has access to it, like what is the rights management process around data in those systems. And effectively turn that into, you might call it a composite view of what you're doing with personal information. That is your data map. It's important to say there's no regulatory requirement to have a data map, but the regulator's guidance in every country and every jurisdiction is basically, if you don't have one of these, it's very difficult to do any of the other things we're asking you to do. But like basically, if you don't know what you've got, how could you possibly remediate the other privacy risks that you have? So that's manual mapping. You've then got to establish a cadence for redoing that map or revisiting the map. Because if you consider that you're continuing to bolt on new products or build new services or extend your infrastructure in different ways, the map changes, right? It continues to modify. So manual remediation is one way to do this, but it's not very scalable. The next is data discovery. So you may have heard talk of this over the last 2 years, this idea of basically throwing ML or RPA at various data sets, structured and unstructured, to try and identify personal information based on probabilistic matching, complex regex, basically, right? The difficulty is just that. It's imperfect, right? It's based on effectively ML, and it's only as clever as the data set it's been trained on. And compliance is binary. This is the thing we forget when we think about this problem, right? Imagine going to the regulator and saying the brakes on these cars that we want to put in the market work 87% of the time. They either work 100% of the time or they don't. They're not compliant. You need to know where all of the personal information is or you don't. So the issue with data discovery that's automated is you still need a manual intervention. Someone's got to review it. So you're never going to dispose of the manual review completely. It's virtually impossible today. So the last option is what we call active data lineage, and it gets closer to some of the methodology that we use internally in our products, our privacy infrastructure tools at Ethyca. But this is the idea of binding together rights management systems that exist, like your directory services and SSOs, with transaction analysis, so real-time visibility of data flowing throughout the organization, and binding that to metadata related to different business processes in the organization to generate your maps dynamically. The next is data subject requests. So some of you may have heard mention of these. So again, subjects are users, right? So think of these as users of your system. The things that you're meant to do for your users, and variously this depends on the market in which you're operating in. So these are for GDPR. GDPR is most comprehensive about DSRs. Canada and actually California are a little less so. So we've given you the most complete version here. So access is the right for an end user of your system to retrieve all of their data. So they can make a request of all of the information you've gathered about them. It's worth understanding here, personal information is what you've collected directly that they've input. It's what you've perhaps collected from them in terms of behavioral data that can be related back to them in some way, or anything that you've simply inferred from them that can still be correlated to them with one other point of personal information. So it's not just customer data or profile data. It's most of the information you've inferred about a user. So you've got to access it, you've got to retrieve it, categorize it into the formats of which a user can understand it, and also the methodology by which you've processed it. Rectification is the idea that a user should be able to edit any attribute of information about themselves if it's incorrect. That sounds easy if it's like profile information, right? Base customer data. But what if it's an insurance company that's incorrectly gathered a health diagnosis, but it's buried in 7 different systems and has flowed through 3 third-party vendors? How do you modify that attribute of data? It's virtually impossible. Deleting it is the same thing, the right to delete a single attribute of information related to that entity. And, bless you, and erasure is the complete erasure of a user. Now, it's worth understanding that the regulator takes a sort of a hazy view on what erasure really represents. So it can be done by effectively masking personal information or obfuscation, right? You don't actually have to do a hard delete, but you can't leave any personal markers there related to the user. If they can be identified from even behavioral attributes, some regulators will take the view that it's personal information. So the best approach is to get rid of it. And then portability is sort of like an access request, so give me all of my data, but give me it in a machine-readable format or some interchange format that I can give to another system. So the idea that I could ask Flickr, theoretically, for my data to give to Instagram, right? There are really only two methods to do this, and they're both pretty painful. Scripts and a runbook are still the most common. I mean, we've spoken to enterprises large and small, and they basically have written a bunch of scripts for data retrieval from various systems based on identities, right? So they have known sets of identities for users, and they retrieve data from that, and they have a runbook in Confluence or somewhere like this. Engineers draw straws on a Thursday night. Whoever gets the short straw spends Friday executing the runbook and hopefully packaging up the user data correctly so that it can be returned to a user through a customer service channel. It's totally unscalable, super inefficient, and really risky. The alternative is, of course, build a subject rights service, right? So build something that specifically implements some kind of interface across all of your data storage systems to retrieve data based on identity. That assumes that you control all of your data and you've got nothing going out to third parties. So extremely challenging, significant cycles in terms of design, development, deployment, and maintenance. So a risky thing to undertake for any busy business. Consent and objection management. I'm conscious I need to move faster. I apologize. We've got a minute and a half left. Consent and objection management. So this is the idea. We've all heard of consent, right? It seems obvious, but it's actually has far-reaching consequences for infrastructure, right? You've got to provide the user the ability to opt in to anything you do. Anything you do is any processing activity of their data. So anything you're doing with their information. You can give them one consent box when they sign up, but thereafter they should be able to manage that quite granularly. So for individual activities that you undertake with their data, they should be able to opt in or opt out. So they should be able to modify those consents at any time. And that then must be able to trickle through all of your systems. So it's not sufficient that you have a record of those, but rather that then needs to trickle down and cascade into all of the systems that are processing that data. The right to object to their data being processed in any way. This doesn't mean they want to be deleted or they don't want to use your service. You're just no longer allowed to use their data for anything. They can still use your services. And then finally, managing their data sales. So this is specific to California. This is the idea that a user does not want you to sell their data to third parties, basically. As I mentioned already, these must cascade through systems. And if you modify a processing activity, so large enterprise in flights, building new services, new products, modifying inferences, team of data scientists come up with a clever thing they want to infer from a bunch of data points. That's a processing activity. That's the user is required to be notified that that's being changed, and they have to be given the option to consent to it. So it's extremely onerous and affects every step of new product development. The most obvious, as I mentioned, is before with all of them is always manual management. It's basically teams of people managing consents, trying to track those into third-party systems, managing where data residency is based on that. It's difficult to maintain parity across systems. I mean, it's super high risk. Consent management tools, you can build one or buy one, something that's effectively a flywheel that sits between your existing products. This is fine if maybe you're entirely SaaS-based, so you don't own any infrastructure. Otherwise, you're still going to be building something to interface with this, so it's not very realistic. And the third option is effectively back to some of the solutions that we look at within Ethyca. So basically binding rights management systems with processing activities. We think of processing activities as roles within organizations. And consent, and think of that as a graph, a multidimensional graph, on which you manage the relationship between what consent users have given for specific attributes of data across systems. Data minimization. I'm nearly there, and I've run over. I apologize. Data minimization is the idea that basically an individual, like a data scientist, an engineer in the organization, or someone in the finance team, or CSM, should only have access to the data they need for the business process for which they've been approved to conduct. Consider the most fine-grained access control system you can possibly conceive of, because we all act on large data stores, but we should only see subsets of that information based on the job that we've been approved for. It obviously assumes encryption of data, limiting of access of data, and logging of the processing of that data. So you could achieve this with theoretically some very fine-grained implementation of a typical roles-based access control system, but realistically that's going to be hard to scale, it's very hard to manage. So the method that we have employed within Ethyca at least is to map activities, consent, and rights together to create effectively a hybrid model that associates the consent that a user is given with types of processing activities which are assigned as roles to an individual user in the organization. It still takes significant infrastructure and ops refactoring to achieve this. And the last one is impact assessments. Think of these as risk assessments for the things you're doing with data. This is vital for everybody to understand and sorely misunderstood by the engineering community. This is the idea that you're basically supposed to assess the risk of anything you build before you build it, vis-a-vis the exposure for the user's data. If it's low risk, you go ahead and build it. If it's high risk, you're supposed to de-risk it by perhaps not processing the data in the way you thought or redesigning the service or system that you're building. And you're meant to maintain an audit trail of paperwork that plans for how you did this. So this becomes part of your product design and development lifecycle. If you're not doing this and you suffer a breach, you're instantly fallible because this is a fundamental paperwork paper flow necessary to demonstrate compliance to a regulator. The way you should think about this very simply is a template for assessing your product engineering and data team's process for building a product. A privacy manager needs to assess that document, or a system needs to assess the risk related to it. If it's low impact, they can build forward. If it's high impact, they need to de-risk it before they build it. And nothing should get built or deployed or managed without that process, which I know seems insane, but those are the regulations. So in summary, you got to do inventory mapping, DSRs, consent, data minimization, and DPIAs. And you could do this manually, or you need to start to think about how you're going to build a scalable stack around this for the future data privacy. That is everything. Thank you very much.
So how much of this is automated versus me manually going in and tagging everything so this way? In essence, how do I not risk running the same security issues that I have with your software that I potentially have with just the way I'm running my operation now?
Yeah, good question. So there's an initial tagging process, which is, think of it as more like abstract data classification. We call it data classes. That's necessary during the configuration process of Ethyca. Once that's done, it's in flight, and it basically uses a combination of transaction analysis for data flow. So it sits in line. Think of Ethyca between data storage systems and your application layers as a middleware between all systems. So it's actively monitoring all transactions, and it's not looking at raw data. It's just looking at entity attribute relationships and generating a log of those against some additional metadata that's configured at the outset. So past an initial configuration phase, the system is self-monitoring.
Other questions? Oh, got you. Right behind you.
The erasure issue, can you really get rid of it?
Wow.
I mean, really?
No, if you're asking can Ethyca, what we can do is tell you where data is flowed to. We can remove it from systems that we have the right to. But if you talk about a large enterprise at scale with like cold storage systems, nobody can. And I don't mean that to be glib. The truth is nobody can. You could have some kind of rotation mechanism over time. So to give you a practical use case, if you've ever tried to request an erasure from Google, you'll typically get a message that it's going to get a rolling delete in 6 or 7 months' time because they acknowledge that there's no way they can meet the obligations within 30 days. So we can delete everything that's current from currently available systems in real time. But if it's flowed into cold storage or a third-party system to which we don't have access, no. But we can see it going there. So we can flag it for deletion, but it's a manual process at that point.
I think we have one more, and then we'll pass it over.
What sort of performance overhead does that sort of monitoring introduce?
Yeah, so no, great question. Very simple answer is that's the thing we've worked hardest on. So we have what we call proxies or wrappers internally. So they're very thin layers. They don't need to make an outbound HTTP request to validate any of the business rules. So we have I could show you afterwards, but we have core services that speak to those drivers on a sort of scheduled basis. But those drivers themselves, to initiate any of the business rules that are necessary, they don't need to communicate outbound. So 4 to 5 milliseconds, very low latency, intentionally. So.
Can you talk about the remediation? Like, so let's take an example, right? Like someone's storing data unencrypted. Like how does your platform, does it remediate? And if it does, how does it?
So the first thing, and again, this will scare everybody in the room, but Ethyca has 2 configurations. One is where you're not compliant and you pick and choose the bits you want. That makes DevOps teams happy. And the other is where you get robust compliance. If you go with robust compliance, which makes you safe, Ethyca's drivers encrypt everything flowing into data storage. You can't touch anything unless you flow through one of Ethyca's proxies. It's impossible. And required. Otherwise, I mean, if you're not encrypting all data flowing into those systems, you're not compliant. These are the behavioral changes we need to make as an industry.
Awesome. Thank you very much. Appreciate it.
So I'm the CTO of a company called Better. We're in the mortgage industry. which is kind of interesting. It's a very strange world. I used to work at Spotify for many years. So a lot of what I'm going to talk about today is basically kind of contrasting like different approaches of how to work with data at different companies. I used to run the data team at Spotify for many years ago, for about 3 years, and then I ran the music recommendation team at Spotify. So built a lot of music, built the core music recommendation algorithm, and then a lot of machine learning stuff, built up a team of about 20. Then I left about 4 years ago and joined Better and have been building up a tech team, and recently I started building up a data team. I have a bunch of open source projects, some random blogs, and some dumb tweets and other stuff. I also co-organized New York Machine Learning Meetup, which feel free to join if you're interested in that kind of stuff. I'm not going to talk too much about machine learning today. Thought maybe we could go back like 2009, like 2008 when I joined Spotify. I interned in 2008 and joined full-time in 2009. This is the second Hadoop cluster at Spotify. I don't know if like people like used Hadoop. It's like a old piece of shit technology that I'm glad people don't really use so much these days. But so this is actually the second Hadoop cluster at Spotify. Probably the funniest bug I've ever solved in my life was I actually put up this curtain behind in the background in order to prevent the cluster from being overheated, so I can run a matrix factorization job. But so what does that mean? What I mean with like data being magic is that because it was all in the Hadoop cluster, like only the data team could like figure out what to do with it, which gave us like tremendous amount of power in the data team. So we were like 3 guys, and we had this like magic power to decode all that data and figure out what the business needed. So people would come to us, and it would ask us tricky business questions, and we would kind of figure it out. And I think eventually it was quite useful. We generated a lot of value for the company. Like, a lot of the data analysis we did was very useful in racing the A round and the B round. A lot of the stuff didn't get done. Like, people would come to us, and it was like kind of unclear, like, would we have bandwidth for it? Probably not. We'd probably we'd focus on the things that we thought was interesting or more valuable. And so I think the biggest drawback of that approach was working at Spotify was a lot of stuff didn't get done. Like a lot of decisions were made that had very huge business impacts that were not based on data because like people didn't have that data. And so when I joined Better, I ended up taking a very different approach. So just like 1 second, let's talk about startups. And there's like 5,000 things you could say about startups and how you optimize startups. But I have a kind of one of my theories is that, besides all the things about, the fact that you have access to capital and access to smarter talent and maybe like different things. My feeling is actually one of the biggest things that startups do differently from enterprise companies or big companies is fast iteration cycles. Like you have this like super fast, super tight loop where you like ship something, learn from it, incorporate it, like move on, move to the next thing. And everything I saw about Spotify, like how people, like the teams that were great versus the teams that were good, it was a large part explained by like having these like tight feedback loops, like shipping things and learning from it and like iterating. And so, so this is something I thought a lot about. And so how do you do that is the question. Specifically with data. I mean, there's like many different other ways you can do it. But I'm going to talk about how to build data infrastructure to do that. One thing that I think is very important, put all the data in one place. Like data is very social. Like it likes to be around other data, so you can like join different data sets. And slightly more controversial, I'm like the world's biggest fan of SQL. It's not like the best language in the world. I wrote a blog post like ranting about how everyone should use SQL for everything. But yeah, it's like not the best language, but like neither is English. But like everyone speaks English, and like if you're starting your own startup, you're not gonna speak like Esperanto just because it's like marginally better, like from a grammatical point of view. Like SQL is like fine, and everyone knows it, and everyone can like sort of learn it, and there's like books and stuff. And so, yeah, so basically my approach was like, people would come to us and I'd be like, just learn SQL, and I gave them access to our database, and like. People started really like taking advantage of this. The legal team, the finance team, the sales team, basically every team at Better is using SQL to query and figure out things, and it's great. What about the data team? I have a very small data team right now. I have a lot of like opinions on like how to build early stage data teams at startups. But like my feeling is like it's kind of like a sequence of like different maturities you go through, and like initially you don't even have data, like you don't even have a product, so like let's build a product, then you get some like users, then you start getting data, and then like finally it's like, shit, we have all this data, we need to analyze it, and then you hire a data team. But not yet like all this sort of machine learning stuff. And I'm saying that despite having run a machine learning team at Spotify, I think most stuff you don't need any sort of machine learning. So what I like to hire for is business sense, most importantly, and coding skills. And this kind of goes back to like what I talked about with like fast iteration cycles. Like if you can have people like taking a project and like shipping it end to end, you get a lot more stuff done. So like one example was like earlier this year, we were like, we should like really analyze like our prices versus competitors. And we thought it was kind of an interesting problem, like so we know like how we should like price ourselves, like we do mortgages, this kind of commodity. And it turns out there's like no data set like that. So like first of all, it's like, okay, let's build a web scraper. So we built this like very scalable infrastructure to like scrape like thousands of rates like every hour, or like tens of rates a second basically, and like stored it in a database. And like a data engineer built that, like a web scraping thing, and had dockerized and productionized and everything. And then once we have the data, now it's like, okay, now we can do all this like cool machine learning on top of that, and like figuring out, and then like go talk to like business people, like how do we use that to like price like slightly below all our competitors and things like that. And so I thought that was sort of like a good example of like people sort of mastering all those domains. Infrastructure, again, I talked about SQL. My love for SQL, it should be no secret by now. There's like not that many options. I can't say like, I don't want to proclaim I'm an expert at the sort of ecosystem, but we're in AWS shop, so we picked Redshift. I think there's a couple of different options. Like we started out with Postgres. Like Postgres is not like a scalable solution, so we ended up switching to Redshift. Snowflake seems to be what people are using these days. And then you put data in the data lake. And I think it kind of boils down to like a couple of different ways. I think there's only like 3 ways actually. Spotify is extremely event logs driven. So we would take like basically all the events that happen at production machines. So they like would write like structured logs, and then we would like ingest that into our Hadoop cluster. And then basically all the analysis was based on that. And it's sort of nice because it's like immutable, like append only, like very structured schema. I think the other approach is database dumps. So we do that more and better. We do both, but more like based on database dumps. So you can set up like read replicas and use that for analytics. I think that's probably a bad idea. I'll get into why later. You can sort of dump data and like restore it. There's some like more like proprietary like third-party services like Stitch and a few other ones. And then there's like random like third parties. So I talked about web scraping. There's a lot of like API integrations we use. One example is actually, this is sort of a screenshot here, but like we use Greenhouse applicant tracking system. Turns out they have like a poorly documented feature for like dumping all the Greenhouse data into your Redshift cluster. So I actually did that. And now I'm able to like analyze the Greenhouse data and like look at conversion funnels for my hiring pipeline the same way as I look at conversion funnels for like users we acquire online, which is great. So yeah, so you can do all kinds of stuff getting data, and then you give people access. So we use a tool called Metabase for like internal like sharing queries. We started using Tableau recently too. There's many other tools, of course. And then you give it about 3 months. If you follow these steps, and like you're gonna get like a massive monster. And so what happens 3 months later, and this happened in about 3 years ago, is you're gonna realize like the finance team has like suddenly built all these like crazy dashboards and reports that like somehow we need for compliance reasons. Like the sales team has like crazy like work queues that they rely on to like prioritize like immediate like answering tickets or whatever, and people's performance is being evaluated on stuff in the database, and it's not just like scary from like a security point of view, but it's also scary because like suddenly like you like expose data and like the whole company is being dependent on it, and you realize like wait a minute, like I'm kind of responsible for this sort of, and you are, and so a couple of things on how we sort of started resolving this. I think ultimately it's like great. Let's just go back to this. It's like all this stuff is like people created value. I'm like very happy I did that, right? Like if I hadn't like provided them the tools, they wouldn't have been able to do this. So like people are like very creative in like coming up with uses for data. And so I think that's a good thing, right? Like rather than like not doing them. It just happens that incentives are a little bit misaligned, so we don't think about security as much. So yeah, so obviously making sure everything is protected with two-factor authentication. You have to like be on the right network and stuff like that. Super important. We ended up using a tool called StrongDM, which is kind of a reverse proxy for Postgres. Maybe it supports other databases too, I don't know. But it basically audits and logs all the queries to make sure you can revoke access and give access and stuff like that. And then also, we started thinking a lot about like how do we encrypt certain data fields consistently in the production database, but also how do we strip them out when we dump them to the data warehouse. So that's another way to sort of make sure that people don't have like sensitive data around. Stuff I learned the hard way. It's been sort of an interesting 3-year experiment. It's really, really hard to take things away. So like you give people like a lot of data, they start building all this like crazy stuff with the data, and they're going to consume it. Especially like real-time access to data. Like people really want real-time access to data. And the easiest way to do that is to set up like a read replica of your database. It's like really dangerous because now you sort of coupled your production data structure to like people's internal needs, and it can be really dangerous. So how do you solve that? Like, I don't know, but the thing I've seen that seems to work is you take something away, you give them like 5 more things. And so in particular, if you want people to stop using, say, like a production read replica, then you add a bunch of really nice data sets in this data warehouse. And you say, you should use the data warehouse. Look at all these great data sets. It solves exactly what you need. You make it a lot faster, too. You do all of this other stuff. And then you like slowly start to restrict access to the previous thing and make it harder and harder. And eventually you end up in sort of a nice state. It's just a long process. Make sure that people's queries are like their own responsibility. Like people across the org are like creating these like crazy reports and dashboards and stuff, and sometimes they break and they come yelling, and I'm like, sorry, you created it. Like you're relying on it. It's not my job. Unless, of course, if it's like a company emergency. But I don't tell them because I don't want to set that precedent. But I will help them, but not tell them that. And then like, set like really tight constraints. This sounds like kind of a minor thing, but we had so many issues where like people would come running to us and they say like, oh, my query's timing out because like the data would get like bigger and bigger. And then it's easy to say, okay, we'll just like increase the query timeout, but that's like a really bad thing because like if you give people more power, they're just going to use it, and then it doesn't matter. Like you give people 2x more power, they're just going to time out their like 2x bigger queries. So you might as well just like set like a really low query timeout and restrict people's like resources pretty tightly, and that way you get a much more stable system. And then finally, with all this like reports all across the company, one of the things we've been sort of saying is like if you really need support, like you need things to be like generated every night, come to the data team. And so, but I think overall, like like this is sort of an interesting. This is like I took the complete opposite approach of the data team that I had at Spotify at Better. And it sort of worked out. Like people are getting things done, and the nice thing is like the data team is now doesn't have to deal with all this sort of what I think was like boring, mundane. Like here's generate this report for me, so the data team can actually focus on some really interesting stuff. That's all I have. Questions? I should add that we're hiring too. If you're interested in the job.
What automation tools are you using? Are you using Selenium, UFT?
I've used Selenium for integration tests or for like the core front end, but not really for data, if that's what you mean.
No, of course not. Data is backend testing, isn't it?
Yeah, I think testing data is very hard. Like I haven't seen any tools like, like you can write like Python tests, but I found it hard to unit test data, like especially ETLs. Cool. What else?
Next question. Yep, you got the mic.
I'm curious about your company's business. Do you originate mortgage by your company in your company, or do you work as a mortgage broker and find a lender for the buyers?
Yeah, so we're the former. So just to repeat the question, we originate loans. Yeah, so we're a mortgage lender. Like, if you want to get a loan, we're not licensed in New York, sadly, but we're licensed in 27 other states. If you want to get a loan, either, buying a property or refinancing, we offer mortgages. It's sort of weird industry I knew very little about when I joined, but it's actually very fascinating. Very, very large industry, completely broken. 7 million people get a mortgage every year. They pay something on the order of $10,000. It's a very large industry, and like everyone who goes through it says it's basically like getting a root canal. So there's a lot to be done there.
You refer to ingesting a lot of data, scraping, and then, so what kind of data were you really going after, keeping that mortgage products in mind?
What kind of data are we going after?
Right.
There's just so much data. Like there's like public data sources, like things we buy. There's of course like all the user data that's generated through the website, all the production logs, but also lots of sort of third-party data sets that we scrape, a lot of other stuff. Yeah, it's like no end to it.
You mentioned iteration speed a lot. What are some tools that you use to power your team to continue to move fast?
Yeah, so for the iteration speed, I thought a lot about this. Like this is one of the things where I have like, my strongest, like very opinionated in terms of like, how do you design the process? So we designed it very deliberately in order to be about iteration speed. I'm talking about the tech team, like as a whole. So one of the things we do, for instance, is invested in very heavily in a CI/CD pipeline. So we're able to deploy like something like 50 to 100 times a day. Very extensive unit tests for everything. Like deployment is obviously fully automated. Tests, obviously, of course, too. We do everything through GitHub, through just pull requests, and we tend to focus a lot on like, small incremental changes, like get them out quickly. Have a very quick turnaround in terms of assigning like a pull request review person and having that approved and getting it out. Yeah, and I think that's like the core of what we're doing, especially when you think about like as a mortgage company, like who are our competitors, like the big banks, like, in a big bank will deploy to production like maybe like, 4 times a year, like every 3 months. Like we literally have 1,000 times faster iteration speed than them. And so I think ultimately that's how we design a better consumer product, is through iteration speed. So I think iteration speed is incredibly important as a startup, both on the data side and the tech side. Actually on every side.
Awesome. Any other questions? Oh, we got one in the back.
What are your thoughts on? You talked about speed, right? So, what are your thoughts on NoSQL or?
What are my thoughts on NoSQL?
Yeah. I mean, it's usually like application teams kind of like NoSQL.
I think it's fine, right? Like if it's like deep in the application stack, if you're using like I don't know Redis or Cassandra or like DynamoDB or like whatever, like to store data, I think that's totally fine. I just like it for like in production services. I actually don't care. It's more like in the analytics stack where I really, really prefer SQL, just because it's like easier and like people don't understand it, right? Like outside of that, I'm not like it doesn't really matter. If I was storing data in a NoSQL database, I would dump it into some SQL database, like for analytics purposes, like for warehouse. Right. Yeah. Awesome. Unless it's like prohibitively big. Even if it was like insanely big, I would just like dump it into S3 and use like one of the Redshift. I mean, like we're in an AWS stack, so like I've used like what's it called, like Athena or Glue or whatever it is. Redshift Spectrum. That's what I'm thinking about. So you can actually just like point Redshift to like S3 stuff and then analyze it using SQL. Just because like again, like data wants to be social. You want to put everything in this like same like place. You don't want to have like data silos. You know what's like worse than data silos is like data silos with like different query languages. It's like the worst.
Awesome.
Sorry, I'm over time.
Well, Erik, thank you very much. I appreciate you coming.